Okay, in this mini lecture, I want to give you more examples about similarity of triangles. We have a diagram here. There's a small triangle PQR at the top and another triangle SRT at the bottom. There are some dimensions given. For example, side PQ is 4 centimeters, side RQ is 3 centimeters. And from the lower triangle RTS, we have side RT 5 centimeters and side RS 6 centimeters. The question is asking us to find the length of side ST, or this so-called X. We need to find what is the size of this side ST. So in order to do this, first of all, we are going to state that the two triangles are similar. And as I said, we don't accept just like that, just because we say so. We have to prove things in geometry. We have to show that. So I'm going to prove that these two upper and lower triangles are actually, they are similar. So I'm going to start by saying that side PQ, so I'm start the proof by saying side PQ is parallel to side T because it is given in the diagram. Then I'm going to say angle PQR, which is this angle here, is equal to angle angle TSR. TSR. The middle letter is the vertex of the angle I'm talking about. So I'm saying angle TSR equals angle PQR. Now, why do I say that? Because these two angles are making a Z pattern. They are called alternate angles. So the reason is because the angles are alternate angles and they make a Z pattern. We remember about corresponding angles making F pattern, interior angles making C pattern, and alternate angles making Z pattern from earlier grades, elementary school. So that's one thing I can say. And also I can say that angle PRQ, PRQ is equal to angle TRS. I can also say that. And this is because these two angles are opposite angles. So we know that opposite angles are actually opposite angles are equal. So I give the reason right beside the statement. So because two angles from one triangle are congruent to two angles from the lower triangle, therefore these two triangles, the upper lower triangles, are similar triangles. Okay? And the conclusion would be here. I would say triangle PQR, the upper triangle, is similar to triangle T PQR. So it will be TSR. TSR. I'm making sure that I put the letters in the correct order because angle P equals angle T, and angle Q equals angle S, and angle R equals R itself. So the reason is angle similarity rule or postulate, which we have discussed it in the past lectures. So I proved that two triangles are similar. Now that they are similar, I can benefit from this. I can say, okay, now that they're similar, this means that the ratio of corresponding sides are equal. So I'm going to write the ratio of corresponding sides. I'm going to say PQ over TS is the same as QR over SR, and it's the same as the ratio of side PR to side TR. As simple as that. We write the ratio of corresponding sides. This is the conclusion that we come up with from the fact that we proved the two triangles are similar. So now we just have to plug in numbers and do a basic, we do a basic algebra and we find the answer. So PQ is 4, I write 4. TS is what we're trying to find is the X unknown. QR is 3. SR is 6. PR is not given, neither required. RT is 5. Okay. So I write all these ratios, but I may not use all of the ratios. I just use the first two. Okay. So if I use the first two, how would I solve this proportion? There's a proportion here. 4 over x equals 3 over 6. So we do cross multiply to solve this proportion. we get 4 times 6 equals 3 times x. So 6 times 4 is 24 equals 3x. Dividing both sides by 3, it gives us x must be 8 centimeters. So there you go. We didn't know what the side length ST equals before. Now we do. It is 8 centimeters. The other sides we can find. We can find side PR if we want, but it was neither given nor required in the problem. So let's add it. Let's say, okay, find side PR as well. Okay, so this time we're going to take the middle fraction 3 over 6 with the PR over 5 fraction on the right instead of 4 over x in the bottom. So I can do it here. I can say, okay, 3 over 6 equals PR over 5, and the cross multiplication will give you 15. So 6 PR would be 15, and then dividing both sides by 6 gives you PR equals 15 over 6, which can be reduced. It's like 5 over 2 or 2.5. So basically 2.5 centimeters. So that is the size of side PR, which of course it was not asked in the question, but we just found it as an additional piece of information. Okay, so now we have all 3 sides of the upper triangle, and we have the measures of all 3 sides of the lower triangle. So basically everything has been found. Okay, I'll try to give more examples in future. Thank you.